Hello everyone, again welcome you all in today's session, that is heat treatment process. And in today's session, under the topic heat treatment process, we will discuss the types of annealing processes. These are known as sub-annealing processes. So previous session, we have discussed about the full annealing process or conventional annealing process. So before starting the session, introduce myself. This is Sagar, working in the Department of Mechanical Engineering, Sagar Institute of Research and Technology. So, oh, again, welcome you all, and let us start today's session with the types of annealing processes. Yes, in the last session, this phase diagram we have discussed. Actually, this diagram shows the temperature band above the annealing process. Heating temperature band for annealing process. This is the A3 curve. This is A3 curve. This is A1 curve. A1 curve. This is ACM curve. And all heat treatment processes are defined on the basis of this heating temperature band. Actually, in heat treatment process, the first stage is heating temperature. So what is the limit of that heating temperature? Up to which temperature heat to be added to the component? So this diagram shows the information regarding the certain temperature for the heating of the metal and metal or alloy. So this diagram is important. These curves are very important. These all are the critical temperatures. E3 is the upper critical temperature for hypereutectoid steel. ACM is the upper critical temperature for the hypereutectoid steel, and A1 is the critical temperature uh, for the hypereutectoid and the hyper. So we discuss the sub-annealing process one by one. The first process, that is known as stress relief annealing process. And all different types of sub-annealing processes that those we are going to discuss in this session. All processes takes place below the A1 curve, below the lower critical temperature. The heating temperature limit is lower the A1 curve. This is common for all sub-annealing processes. So what is the objective of stress relief annealing process? Objective is to relieve the process, annealing process. Stress relief annealing process is used to relieve the stresses developed during cold working machining and welding processes. Yes, welding and machine working machining. Earlier, uh, during the earlier processes, if the stresses are developed, then how to relieve those stresses from the material so that the properties can be improved. This is the objective of the stress relief annealing process. The stages are common, those that we have discussed: heating, cooling, and uh, heating, soaking, and cooling. This is yes. So heating below recrystallization temperature. The material or alloy is heated below the recrystallization temperature. Actually, this is the eutectoid temperature. So under the stage 1, the metal or alloy is heated below the recrystallization temperature around 550 degrees Celsius. It means below recrystallization temperature means below the A1 curve. And this temperature around the 550 degrees Celsius, that is below the 725 degrees Celsius. Then holding it, after that cooling is carried out. Uh, Cooling, this is related to cooling. Cooling is not specific in this process. Cooling is not specific because there is no transformation occurring. Yes, in this process, transformation is not taking place because the process is taking place below the lower critical temperature. So there is no any transformation. Whole processes is going on below the eutectoid point. So there is no any transformation. So cooling is not specific, but slow cooling is enough. Slow cooling is recommended so as not to introduce any thermal stresses. So in this case, the slow cooling is required. Now, expected microstructure are properties. Yes, after applying stress relief annealing, what will be the results? So, no significant change found in the microstructure and stresses will be relieved. But yes, in the microstructure, no significant changes were found, but stresses are relieved and properties will be restored as observed before a particular operation. This is the improvement found after applying the stress relief annealing process. Now, the second process is known as re-slice and annealing process. What is the objective of re-slice and annealing process? The objective is to get fine or refine grain microstructure of the steel after passing through cold burning. Yes, if the metal or alloy is passed through the previous any manufacturing process like cold working. So, how to refine the grain microstructure? So, recrystallization annealing process is one of the method uh, that refines the grain microstructure of the steel. The second objective is to store strain hardening capacity of steel if the steel gone through the cold working process. So these are the two objectives of the re-slice and annealing process. One is to refine the grain structure. Number second, to restore the strain hardening capacity. Yes. Now the process. Under the process, the stages are common: heating, soaking, and cooling. So the process, the steel R component is heated below the critical temperature, that is A1, and this temperature is around 625 to 675 degree Celsius. And in the stress revealing process, we found the temperature range that is 550 degree Celsius. It means this process takes place above the stress relieving process. Cross temperature is little high as compared to the stress relieving process. Then second stage, holding at their temperature for some period of time to make changes internally. Then cooling is please correct this spelling COOLING. Cooling is allowed, and here also the cooling is not specific because the process is taking place below the eutectoid point, and there is no transformation occurring. But the slow cooling is required. Yes. Now, expected microstructure or properties will be the what will be the result after the crystallization annealing process. These are the results. Fine re-sliced microstructure is found. Strength is found good. It means strength increases. Good ductility because of grain. So these are the uh, expected microstructure and the properties if we use re-crystallization annealing process to the metal or alloy. The next process is known as bright annealing. Yes, in the bright annealing process, some protective medium is used during cooling of steel to prevent oxidation and decarburization of the steel or alloy. This is the objective. During the cooling of the steel or alloy component, some protective medium is used that prevents oxidation and decarburization. And as a protective medium, what protective mediums are used, and those are like H2, CO, CO2, and CH4. These are the protective medium. Those are used during the cooling of the component. And this protective medium makes the surface bright, and hence it is called bright annealing process. Yes, as it name appears bright, right? This is the motive of this process. The protective medium that is used in this process that makes the surface of the component bright. That's why it is known as bright annealing process. Now next is box annealing process. What is box annealing process? In this, the annealing is carried out in the sealed container under the conditions that reduces the oxidation. So it is called as box annealing. Yes, to reduce the oxidation, the box annealing process is used. Component is paired with the cast iron or charcoal, and the process is carried out into the container or box. And the stages of the processes are common: heating, holding, and cooling. Then next is isothermal annealing process. In this process, the component is heated to the desired temperature. And what is desired temperature? Below the A1 curve. Below the A1 curve means A1 curve shows the temperature that is 727 degrees Celsius or 725 degrees Celsius. And hold it for 20 minutes for completion of transformation, and then it is cooled below A1 temperature up to the room temperature. What are the advantages of the isothermal annealing process? The advantages and the results are found. Meshability was found improved, and surface finish was found improved. These are the advantages of the isothermal annealing process. So, thank you. Now, before ending the session, now let us conclude the session. What we have discussed in today's session, we have discussed the different types of sub-annealing processes, in which we have started from the stress relief annealing process. Second, we discussed about the um, recrystallization annealing process. And next process we discussed about the bright annealing, then Bots annealing, and the last we discussed about the isothermal annealing process. So these are the sub-annealing processes. And in the university examinations, sometimes one question is asked from the annealing processes and the sub-annealing processes. So thank you all of you.